Thank you so much for being here, and we're really excited to show off what we built on Eighth Wall. Pablo gave a little bit of my background. I first got involved with Eighth Wall through the Memory Space Chinatown AR experience, which if you're in the Los Angeles area, you can go down to Union Station and check out right now. We work to recreate the original Chinatown of LA and allow you to use your phone as a portal to like step back in time to the 1920s. Um, and we specifically worked with Eighth Wall because we wanted to create a way that people just getting off the train or just passing through the area could experience this without having to, download a full heavy AR app. So that's a experience we're still building and but you can check out right now. So this is my second project and really excited to show it off to you guys.
Awesome, Kim.
I'm Kim. I'm one of the two engineers on this project. This is my first experience with Eighth Wall, so it's been really fun to develop this project. I've been a engineer at Cloud Kitchens for the last 3 years, working on food automation, food production automation and food service automation. And I graduated with a degree in information science and a focus in interactive technologies from Cornell.
Ben.
Hey guys, I'm Ben. I am a self-taught engineer actually. I have been working as a web developer in San Diego for a few years now. This is my first experience as well with any XR stuff. On top of first experience with Eighth Wall. So yeah, it was a really cool experience. Yeah.
Awesome. All right, so I'm going to stop my screen share. You will no longer hear from me until the very end, and I'm going to pass it over to the team. Keep an eye on the chat. I'll be dropping some useful links for their experience. And yeah, go ahead, Tyler.
All right, thanks, Pablo. And just give me a moment. All right, can everyone see UFO Rodeo slide? Good to go. All right, well, I'll open with a little promo video we put together. But I guess as just a brief introduction, this is a mini game that we are continuing to grow into this year. I really love UFOs, and thought this would be a fun way to get into Niantic Studio and obviously play around with the fun UFO lore. Kim and Ben are much smarter than me and thankfully could bring the technical side of things to life. Right now, this is an experience you can play just in your room, but soon to be, or anywhere really, but soon to be VPS enabled with way spots in your local area. And you can see a little preview featuring my dad as a farmer defending his flock.
My cows are missing. What the? My God. UFO Rodeo. Play now on Niantic 8th Wall.
There you go. Play now. Um, all right, so going into the meat of this talk today, is obviously the technical side, how Kim and Ben built this bad boy. So we thought we would make it easy for any of you that did want to follow along or use any parts of our code. We've broken down the major components into 3 sample projects. So you'll see a preview of those projects coming up, some QR codes to open it up on your own phone, on your laptop. And now I will hand it over to Kim to talk about the high-level architecture.
Cool. Do you want to move to the next slide? Oh, thanks. Okay, so I'm going to be giving a brief overview of the architecture. So for those of you that are unfamiliar with Niantic Studios, they use an entity component system. And in this system, there are entities and components. Entities are general purpose objects, and the components are reusable attributes or behaviors. And these can be attached to the entities. So to manage our project's flow, we used the built-in state machine, which allowed us to define the behaviors of these entities. And we used 4 main states in the game manager to control the life cycle of our game. We had the init state, which was used to retrieve and load assets before any of the content was displayed, and this helped with the performance of our game. And then we had the start menu state, which displayed game rules and provided an entry point for the user into the game action. We had the game state, and this is where we initialized the game stats, added event listeners, and dispatched the game state. I'm going to talk more about this in the next slide. And then the end menu or end game state. We also had each entity component implements its own internal state machine to manage its specific behaviors. And then we had this for the cow entity and then also for the UFO entity. As for how we structured our data, we held primitive types in the component schemas and then assigned our more complex data structures to global variables in their respective files. And we did this because the schema variables were limited to only primitive types. We can move to the next slide where I'll talk more about the gameplay loop. So the manager state machine orchestrates the interactions between the UFOs and cows through events. During the game state, it maintains a cow map, which tracks which cows are targeted by which UFOs, and then handles events like get cow, which is when a UFO needs a target, cow abductive, when a UFO successfully beams up a cow, and zap, when a player hits a UFO triggered by a tap event. And when the manager transitions between states, for example, between like the initial state and the game state, it broadcasts global events like game start and game end, which trigger state changes in both the UFO and cow components. And this effectively synchronizes their behaviors with the overall game stage. The cow state machine simply alternates between 2 states, so hide and show. Hide where the cow is invisible and inactive, and then show where the cow becomes visible at a random position on the field via a random offset. And basically, either a cow is abducted, aka gone, or it is grazing and visible. So the logic here didn't need to be too complex. The UFO state machine implemented a bit more sophisticated of a behavior cycle, just because of the range of activities that the UFO component had. Each state had defined entry behaviors, transition conditions, and timing parameters like roaming animation timing and beam duration. These controlled like how long the UFO stayed in each state before transitioning to the next one. So brief overview of the UFO life cycle. The UFO started in the init state, and then moved to alternate between the roam ping and roam pong states while searching for targets. Roaming was one of these sample projects that we had, so Ben will go more into detail on the code there. And then from there, it could transition to the seeking state. When a free cow is found and assigned to a UFO, once it's positioned over the UFO, over the cow, we'd move to the beaming up a cow state. And then at any point, a UFO could be zapped by a player, which was triggered by a screen tap event. Now I'll hand it over to Ben to talk more about our sample projects.
Cool. Thanks, Kim. Yep. So as mentioned, we made 3 different sample projects, just extrapolating different systems that we built within UFO Rodeo, so that people can view them in their own context and use them in their own projects, basically. So you want to go to the next slide. Cool. And I think we have QR codes for each of these if you want to go to those links and check out those sample projects. Our first sample project is the spawning system. So one of the things we did with UFO Rodeo was we wanted to spawn all of our entities in programmatically, as opposed to having a set amount of them within our game space, just so that once we had implemented our game state and all of our logic, we could go back and essentially, fine tune all of these different parameters, like how many entities of so-and-so are we spawning on the fly, just to adjust the difficulty more easily. And so that's why we made the spawning system. You want to go to the next slide? Cool. So I'm just going to walk through this little state machine that we have defined that pretty much encapsulates all the logic for spawning in entities dynamically. What we're looking at is a snippet of code on a component within the entity component system. You can attach these code snippets to entities within your 3D space, and it'll give them interactivity, and you can interact with the game world with code through these. So one of the parameters on these components is a state machine, which allows you to define a basic state machine within your component and define somewhat complex behaviors within that. So we defined 2 different states within our state machine for this system, a loading and a done state. All of the work is done in this loading state. If you're using it for your own project, maybe you would call it like initialize or whatever, load in your entities and just initialize all of them. So we define our state for loading. We mark it as the initial state. So that's the state that the component will default to when it's spawned in. And then we have a callback to on enter, which is where all of the work is done. So within there, we are grabbing 2 variables, entity amount and spawn speed, from this thing called schema attribute, which is an argument that components will take that you can populate through the user interface. So when you attach a component to an entity, you can configure these values within the schema attributes from the UI, and then your code will respond to that. So we have entity amount and spawn speed here that we're taking in. So for this example, we're looping as many times as the entity amount and spawning in entities. And we wrap that in a set timeout within with the timeout of the spawn speed. If you were doing this in your own game and you just wanted to initialize everything, you probably wouldn't set it in the timeout. But we did this just so you could visually see things spawning in, and to show that you can kind of pass whatever arbitrary arguments you want to your code through these schema attributes. And so the logic within the loop is basically, we call world.createEntity. World is an API that is provided by Niantic Studio that allows you to interact with the 3D space of your game scene. And then after we create our entity, we use the other API that is supplied by Niantic Studio called the ECS API, which allows us to set different attributes onto that entity. So here we're setting the GLTF model, which is like our 3D model that we assign to our entity. We're assigning a scale animation, which basically makes the entity like grow up like out of the ground when it spawns in. We're adding a collider so that if an entity is spawned on top of another one, they'll push each other away. And then we're grabbing the camera position and we're giving a random offset on our X, Y, and Z axes to spawn the newly created entity somewhere within the camera's view. And so, once you add all these attributes to your new entity, you'll be able to see it at runtime in your scene, and you won't have to have any predefined entities within your UI or your game scene in Niantic Studio for, say you want to spawn in a bunch of different things. This would be a way to do it. And then at the end, we just have a trigger to move from the loading state to the done state. If you were to use this in your own game, maybe it would be you go to your main menu state or you go to the start of your game loop. And that's basically it for the spawning system. Our next one was a scoring system. We have, if you remember from the little, the incredible masterpiece of a trailer we have for UFO Rodeo, there's a little counter at the top for how many cows you've lost and how many UFOs you've zapped. We basically use this sort of scoring system to keep track of that. And we added little particles to the sample project because why not? But yeah, so going to the code, you'll notice that we are not using a state machine for this specific example. We're showing off another attribute on the component object, the add and remove attributes. So basically add allows you to run some code that will help you initialize the entity that it's attached to on load. So, say you have like a blank object in your game scene for like a manager, you could add some logic within this add callback to like get your scoring system set up, which is what we do here. So we grab our schema attributes like we were talking about before. We also grab data attributes, which is essentially the same thing, except it's internal to the component itself. It's not accessible from the UI. So if there's like internal state that you need to keep track of that you don't want to have configured from outside of the component, it's like having, like a private property or something. So then basically we just define our different functions that we're going to need in this context, since they have access to all of the variables that they'll need. So we have our update score function, which takes a reference to our UI component at the top, just updates the score, pretty straightforward. We have our create particle effect function, which will just remove the previous particle emitter property from whichever square you click on to increment or decrement, and add a new one so that it'll play again. And then we have our increment and decrement functions. Also straightforward. We just get the current value of our count, which is a data attribute value, and we either add or subtract 1. And that's pretty much it. And we update the score as well. And then the way we make that all come together is within the World API. There is an events API where you can add event listeners to entities or the global game object or state. And so basically we're attaching to our increment and our decrement entity a touch event with a callback of our increment and decrement functions. And then we have a little add cleanup and do cleanup thing that's kind of defined outside of this code block. You don't need to worry about that, but really we just kept it in there to remind you, if you add event listeners, clean them up. And that's it. That'll give you a whole scoring system that you can keep track of to monitor state within your game. Our final sample project, roaming entities. If you remember, Kim was talking about one of our states for our UFOs. One of their internal states was roaming, and that state was made up of 2 different states itself, ping and pong. Basically, we recreated that in this sample project, so you can have an entity look like it's moving around randomly, So we used state machine for this once again. That's, I think, going to be a pretty common way to tackle any sort of interactivity within a game that you make within Niantic Studio. It's a pretty powerful pattern. And so within our state machine, we've defined two different states, ping and pong. And basically, we have this handle roam function that will get the current position of the entity that you've attached this component to. It'll create new coordinates with a random offset from that position that you've just grabbed. Excuse me. And then it'll set a position animation to go from previous position to the new position. And as you can see, we have a little duration there of 1100 milliseconds. Basically, it'll move from point A to point B in that amount of time. And so the way we use that is we define our different states with the ECS API within our state machine. We'll define our ping and our pong state. We've just arbitrarily chosen ping as the initial state. And then, so on enter for either of these states, we call our handle roam function, which will move it. And then there's another callback that you can use called wait when you define a state within your state machine, which will just do a, you supply it a certain amount of milliseconds, and then it'll transition to the next state that you define as the second argument after that amount of time. So we've just taken the 1100 milliseconds of the animation and then added a random couple hundred milliseconds beyond that for it to wait. So it looks as if it's, you know, kind of moving with some sort of randomness. And yeah, once you put those together, they're just basically calling each other back and forth, and it'll look like it's moving around in 3D space. Excuse me. And yeah, so within our UFO Rodeo, you know, we wanted the UFOs to seek a cow, or like, you know, do more than just go back and forth. So if you were to expand this for your own project, maybe you would keep track of how many cycles of like roaming that your entity has gone through like a data attribute, and then after a certain amount you can move to another piece of state. So yeah, that's pretty much it.
Okay, I'm going to talk about some of the challenges that we faced during our development. So first, the UI entities proved restrictive. We resorted to using basic HTML solutions like plopping PNGs on top of our game with high Z indexes and making arbitrary portions of the screen clickable, instead of having non-rudimentary solutions like implementing a button. Next, I guess while it was clear how to create and edit objects in the UI, we initially really struggled with spawning entities programmatically, largely due to the fact that there were unclear property requirements. So even like one of our initial solutions to generating the UI elements was to create an element and then clone it repeatedly. So I think improved documentation here could help mitigate this. The next one is pretty straightforward, but often the same piece of data wasn't consistent across the system. So for example, a data attribute in the onAdd function would be an object form, and then accessing that same piece of data in a tick function would be a string. Next, the data and schema attributes were limited to primitive types only. I think I talked a bit about this, but I think more complex data structures were a necessity for this game. So we resorted to use globally defined variables instead, but it would have been a lot cleaner to store these objects within the manager. And then some potential solutions. So it would be really useful to have an enhanced LSP integration for better code completion. As stated before, it was sometimes difficult to tell which properties were available to us, as well as the types of the props. And then also standardizing the component arguments. So ensuring that they all contain the same data attributes with consistent types.
Yep, and so as far as learnings that we've gained from our experience with Niantic Studio, there were some challenges, but overall, it was really cool to be able to work with a game engine that will create WebXR games like just in a mobile browser. It's pretty impressive just to think about that in general. And as we mentioned earlier, this was Kim and I's first time using an entity component system, which is a fairly common pattern within game engines, as far as I know. And so being able to be introduced to it in like a web format, which we're both familiar with, was very helpful to us. I'd say if you were new to programming and you just learned a little bit of like JavaScript or something, like it would definitely be doable to go in and like learn this sort of system with a limited knowledge of programming. So I think it's a nice, simple enough environment where you can go in and build like a nice, smaller scale WebXR game with not a lot of programming knowledge, which is pretty cool. We also learned a couple things about just architecting, different patterns of architecting your code. Since this was our first like game experience, really, there were a couple patterns that we used. Like we had an event-driven system, so that our different components could talk to each other and manage game state by sending events out, and just making sure that we had we built in a pattern where we could go in and tweak different attributes from the UI after we implemented everything to balance the game. Was a good learning process. So yeah, definitely a lot to learn from working in Niantic Studio.
All righty, thank you all. I think that's your last slide. Yep, huge thank you. Cool. Yeah, thanks everyone for tuning in. We are now going to jump into our Q&A section. If you have a question that you didn't already write in the Q&A, just raise your hands and we can ask that directly to the team. We do have one question for general like studio, but I wanted just to ask you all, Tyler, what's next? I know you spend a lot of time on this game, and it seems like these are just kind of like the starting blocks for this. Like, what do you all plan to do with this game next?
Um, yeah, I think I mentioned just briefly at the beginning that VPS is definitely a major uh, next step for UFO Rodeo, So you've successfully defended your flock at your ranch, but the aliens are hungry and they're coming for all the other cows, sheep, and other livestock in your local area. So it's up to you to defend your greater and larger community. So, and the technical side, the VPS weight points that are in local parks and open areas wherever you live will be other ranches, and you'll go on to the app and you'll see, you know, Farmer Smith, help, help, they're coming from a sheep, and you got to get out there and you got to defend those sheep. So there'll be kind of local leaderboards of the different local ranches, and you can become kind of the chief alien defender of your community.
I can't wait to be the chief alien defender of Glendale. This is going to be
Mhm.
a
We need
great,
you.
yeah.
Glendale needs you, Pablo.
Awesome. All right, so we have one question regarding Studio that came in through the Q&A, and I'll direct that to either Evan or George, whoever unmutes first. Can you also use USD files instead of GLTF?
That is a good question. I actually don't know. I haven't tried, but I would say give it a shot. If it doesn't work, you should be able to convert it to a GLTF in like Blender or something. Which is usually the better option anyway, just because GLTF and GLB are optimized for web and they have far less issues than any other format. Yeah, and just while I have your attention, don't use FBX. If you don't want to lose your mind, don't use FBX.
Fair. Thank you, George. We have another question from Sultan. Is there an API that allows us to import a map similar to Pokemon Go where users can visit specific locations / scan objects? Stay tuned. Next week, we will be making an announcement in anticipation for the start of the new challenge. And that's all I will say for now. But yeah, we're excited for that. It's a mix between Pokemon Go and Destroy All Human. Yeah, definitely. And then Christopher asked, and then Tyler, maybe you can answer this. And I know George and Evan, you might have some insights. Are there any concerns with the risk of people playing this game in public?
That's such a great, just philosophical question when it comes to VPS-based public AR gaming in general. I think the biggest risk is, well, it's a new way of kind of playing games in public, right? And I think people generally are like, why is there a phone out? They might think you're filming them. But I think if you're like moving around a lot and you're tapping your screen, you might look a little silly, but you'll also look like you're having fun and probably don't look like you're a threat. We're definitely focusing the VPS locations to like safe open areas. So it won't be like any kind of physical danger, obviously make sure your local parks aren't sus for other reasons, but maybe we can add a little flagging feature or something for park safety. But yeah, if you had any specific thoughts, I'm definitely curious.
Yeah, so for those of you that are more worried, less so worried about looking embarrassed or feeling embarrassed, our activation for VPS locations do take those kinds of things into account. Is the location safe? So you can't approve, we won't approve a location that's in the middle of the street, obviously, for obvious reasons. And then also no private property location. So they all have to be public. So there's no risk of, trespassing and all that jazz. Uh, Additional question from Christopher. Do you plan to add any co-op features in the future?
Yes, that would be a super awesome feature. I know we had uh I can't remember the specific name of the module, but back when I was testing out in the cloud editor, the sorry, Pablo, you if you have the name on the top of your head, but the co-op AR,
Oh, shared
um,
AR.
shared AR, definitely something we'd love to implement. And yes, and that's a great way to also make this a more, less worrisome activity in public. Go with friends, and soon, yeah, you can have two ranchers in the same party shooting those aliens.
Awesome. Okay, so let's see. We got two questions. This one might be better for George and Evan to answer. Is there any specific criteria to enable VPS location?
Yes. So if you go to our docs page and you click on the Lightship VPS section, it has some general criteria, but the general idea here is that it does go through a review process from the Lightship team. So it has to be publicly accessible. It has to be a real place. It has to be like a notable location. Like you can't just go outside and like submit a mailbox as a public location. But you could do it for a private location. So there are some things there, but in general, it's just got to be public, safe, and like reasonably accessible.
Yeah. I just also dropped the link for that specific part of the docs so that you can review on your end. And that also goes through how to link Scannerverse to your geospatial browser. So it's a really great place to get started to learn everything you need to know. We have a next question. This goes out to the team. Tyler, will you be implementing more weapon types or upgrades for those weapons? For Cal, the laser ray may work, but for sheep or there's maybe other types of weapons. Yeah, that's an interesting question. So you have to unlock, as you unlock new locations, you unlock new weapons. I think everyone's just giving you ideas for how to make this game even better and more fun. So that's
Yeah, if you guys want to help, you have some ideas for some 3D models and custom weapons, hit me up. I'll put my email in, and I think it's also on our page on the UFO Rodeo 8th wall page. But yeah, absolutely.
awesome. And then we have a comment from I'm sorry, I'm not going to try to pronounce that, but if you want to unmute and let me know how to pronounce it, I'm happy to hear it. But essentially, the question is: Scannerverse is unavailable to download in the country I am in. Will there be an update to expand to other countries? I think, George and Evan, this might not be a question that you can answer here, but we can definitely follow up after the fact with the Scannerverse team. Could you respond to that comment and just let us know where you're located so that we can ask that question to the right team members? But I don't know, Evan and George, if you have any insights. Turkey, got it.